All right, we're ready for the review for the probability quiz on 11.1 through 11.3. The first section really doesn't deal with probability, it just deals with total possible outcomes. So if you read through the first problem, it says, the principal of the high school selects 4 merit scholars to attend a town council meeting. There are 12 merit scholars at the school, and how many ways can the students be selected? I would look at this and say I'm selecting a group of 4 out of 12. That tells me that it's not counting principal, it must be combination or permutation. I would say that because it really doesn't matter in which order the scholars are selected, it makes no difference what 4 students, if you want 4 particular students, it doesn't matter which of those students comes first, it just means that you want those 4 in any order you feel like. So order in this case doesn't really matter, that makes it a combination. So we're going to use n factorial over r factorial and n minus r factorial. R for this problem is 12, R for this problem is 4, and n is 12. So what we really have is 12 factorial over 4 factorial, and then n minus r would be 8 factorial. So on the top I've got 12, 11, 10, 9, 8 down cancels with the 8 factorial, and then this 4 factorial still left over, 4, 3, 2, and 1. So I got a little bit of math to work out here. I'll use the calculator just to do it very quickly. On the top, 12, 11...
Mr. Barron's still in the building. Call the office. I have a phone call for you.
10 to 9 is 11,880. And on the bottom, 4, 3, 2, 1 is 24. So I would divide that again, and you end up with 495 possible ways that can be done. Okay, the second one says, a football team is having t-shirts made, 4 styles, 6 colors, 3 logos. How many different ways can a team have a shirt made if they choose one style, color, logo? Here's the key, choosing one. If you're picking one out of each category, that kind of leads you to counting principle, which just says multiply the number of possibilities of each thing together to get the total possible. So it's 4, 6, 3. 24 times 3 is 72. Final answer for that one. The next one says the teacher is passing out first, second, and third place prizes for best student actor in a production of Hamlet. 14 students in the class. Okay, 14. You've got 3 things to give out. So you can see that order matters, right? Whoever you select, if that person is first, then nobody else can be first. So it depends on who you pick in which spot. So we're going to choose 3 out of 14. But because the order makes a difference here, I'm going to use permutation instead. That's n factorial over n minus r factorial. So we've got 14 factorial over 11 factorial. That's going to be 14, 13, 12, and everything else we cancel. Multiply it on a calculator. 2184 is your answer there. Okay, we go on to the next part. We actually get into a little bit of probability. One type is geometric probability, where it says find the probability that a point chosen at random inside this larger square will also fall within the smaller square. So it's kind of like saying, okay, I'm going to blindly choose a point, and I want to know what's the probability of that blind choosing point falling right here in this little square. So what I really am saying is that the smaller square here is the good area, and the total square, or the big square, is the total area. So any kind of geometric probability is usually the good area over the total area. So this is just a square. Area of the square is side times side, side squared, or length times width, but they're the same. So no matter what you do, the square in here is going to be 1 times 1. So the good area is just 1. And the total area is 3 squared, which is 9. So this probability is just 1/9. All there is to it. So the next one says a bowl contains 22 blue, 14 yellow, 75 green, and 19 red jelly beans. What's the probability of selecting anything other than a red or yellow? Anything other than red or yellow. So first thing I need is all of the total jelly beans. You gotta add up 22, 14, 75, and 19. I get 130 total. And then I'm going to say, well, okay, I don't want red. I don't want yellow. So basically I need the 22 blue or 75 green, that's 97 total. I don't think 97 over 130 reduces, but just in case, we'll check it on the calculator. It turns out it does not. So this is your final answer, 97 over 130. I always want to make sure you give the most reduced answer possible. Okay, this is your independent and dependent probability where you have multiple things going on at once. This one says, suppose you have a bag of Skittles between 5 yellow, 8 red, 6 green, 3 blue, and 11 purple. What's the probability of selecting a red Skittle, putting it back, then selecting green, eating it, and finally selecting purple? So you have 3 separate things going on here, right? You're picking a red, you're picking a green, and you're picking a purple. But you have other information that you need as well. Let's start with the probability of picking a red. Well, first thing I do is total up all the Skittles. So I got 13, 19, 22, and 11. That's 33 total. And to get red, it would be 8. So 8 out of 33 is the probability for the red Skittle. Okay, that's taken care of. Now it says you put it back in the bag after you pick it out. Okay. So then you have to select the green Skittle. So basically I still have 33 Skittles left in the bag because I put the red one I got back in it. So the probability of picking the green would be 6 out of 33. Okay. So that takes care of the green Skittle. Okay, it says you eat the green Skittle, so you're down to 32 Skittles. And finally you want to select the purple one. So I have 32 Skittles left in the bag now because I ate the one green one that I picked out. And there are 11 purple, so 11 out of 32. Those are the 3 individual probabilities. Now the question is what is the probability of the whole thing happening? The understanding here is that picking a red Skittle isn't really that hard. It's an 8 out of 33 chance. You know, it's just a little more than 1 out of 4 chance. But to have it happen where you're picking red, then green, eat the green one, then pick the purple one, just like that, in that exact order, ought to be a lot more difficult because it's something kind of a very specified situation. So you actually have to multiply each one of these together. 8, 6, and 11. I get 528. Then 32, 33, and 32. I get 34,848. Okay, a big fraction like that, you know, if I can help it, I want to get rid of. So you can make it a percent if you want, or you can reduce the fraction on the calculator. That fraction reduces to 1 out of 66. So it means there's a 1 out of 66 chance of it happening the way that we set it there. Red, in the bag, green, eat it, finally pick a purple one. Okay, so then we go to part B. It says, which parts of this probability event described in part A are independent and which are dependent? Well, basically what you're looking at is the first one is always independent because it's the first event. There's nothing before it to affect it. So then, okay, that means that the second event, it can be independent or dependent. Let's see. Well, it's picking a green Skittle. Normally that probability would be 6 out of 33. Well, in this case, it's still 6 out of 33 because you put the red one back in the bag. So it's like you started the event over again. So whether this first event happened or not, whether this happened or not, doesn't really matter this probability still ended up being 6 out of 33. So it turns out that the first one was independent, because it's the beginning one, and the second one's actually independent too, because you didn't really change anything. So then you eat that green Skittle. So then the purple Skittle probability, that one normally should be 11 out of 33. But in this instance, it's 11 out of 32 because after you did this event right here, you changed the probability because you ate a Skittle. You changed the scenario. So because you changed it, this probability, the purple one, depended on the fact that you changed it from the green one. So your answers to this are that the first two events are independent and the last event is dependent. I wrote that all out right here for you if you want to see a nice detailed explanation. And finally, we're on to the last problem. This is a pretty short review, which is good. It says, using that chart from example 2, so hopefully you have your paper you can look at. It says, what is the probability of randomly selecting a student with a B average? I would stop right there. That's the first piece of information that they give you in this problem. That you're selecting a student with a B average. Stop right here. That's the first thing you get. That tells you the total group of students you're going to look at. So I'm going to take the column that says B average and add all those up. It looks like you get 35. 35 total B average students. And then I want the ones that do not play basketball, which would be the 5 soccer and the 22 football. That would be 27 out of 35. That doesn't reduce, so your problem is done. That's the end of the probability review.